Okay, guys, check it out. It's my mystery box. I have no idea what it is. Got this from a garage sale. It was sitting in underneath a table that had a bunch of old rusty tools on it. My wife had to stop, look for her little knickknacks, and me being a guy, I gravitated toward the rust. Anyhow, I asked the guy what it was because it intrigued me. Knobs and buttons are cool. And he had no idea what it was. I didn't know what it was. And so I asked him how much he wanted for it. He said $10. Well, that's a little steep for something you don't want. And I ended up offering him $2 for it, and he took it. So I have this mystery box here. It's got a knob on it. Seems to control something. A voltage meter runs up to 5 volts or 50 milliamps. I guess it's got 2 scales on it. And it's got these 3 pins on here. One marked V, one marked C negative, and one marked A. So then got a power cord, plugs into the wall, and all these connectors on the side. 4 of them are marked, 1 through 4. The last one isn't marked with anything. So I'm going to try to figure out what this is, what it does. I'm not plugging it in until I know. Could be a time machine. Nah, I doubt that. Anyhow, after looking at it a bit, I haven't opened it yet, but after looking at it a bit, it looks like they built 2 separate boxes. There's a split that runs all the way around this thing, and the only screws that seem out of place are these 4 on top. So I'm guessing that it was designed to come apart in 2 pieces. So let's take them out and see what it is. Alright. Four screws. Oh yeah, there's a handle on the back for carrying it, so whatever it was, he meant to take it places. So, let's find out. A little tight. There we go. There it is. Now, there's a lot less in there than I expected. Big, well, not a transformer, some sort of a rheostat, kind of like a turn knob. Looks like looks like that's used to adjust some sort of voltage or something, because it's a pretty high current device. It's got a series of diodes. It's like power diodes in here. And the strangest thing, all those connectors on the side, I don't know if you guys can see that. There's no wires running on any of those connectors. It's just a blank box. Wow. First glance, it looks like a crude power supply. One wire is disconnected. Looks like it goes on that loose screw there. Let's see. Okay, this rheostat. Let's see. Common ground, line load connected, use terminal 2 and 4. General Radio Company, type 5 watt. Okay guys, sorry about that. My camera stopped recording for some reason. We were just reading what this was. Now I'm all messed up because the camera messed up. I was on a roll too. Anyhow, that wire that was loose, I tightened. Well, man, it keeps coming loose. But this guy had all kinds of trouble with this, whatever it was. There we go. Anyhow, what we determined was this is some sort of a rheostat, and it's got a series of diodes inside, and that's it. Everything else is gone. Doesn't look like it was ever hooked up, so I'm guessing this used to be a project box for something else, and it got reappropriated. Not uncommon. I do it myself. So, unfortunately, I've already been through the whole spiel because it was... Man, my coat's so puffy. Anyways, what we determined is the power line coming in runs all the way up, hooks the rheostat to the load and the common right there. The common is on the same terminal, runs right on down into one side of this set of diodes. And the load runs through the rheostat out to the center on it. So I'm guessing the rheostat itself is acting as a transformer since it's on both sides of it. Either this has two sets of loads in that inside there, or yeah, it's two transformers, so it's varying voltage or something. Anyhow, the common side runs the other side of this bank of diodes. So each end of the bank of diodes, top and the bottom here, have one of the two power wires on it. Then we have the 3 pins that we were talking about. The one marked V runs around here, and V? No, A. Sorry. A. One marked A runs to this bundle going to the center of that bank of diodes, like a rectifier it looks like. Should be a rectifier, I'm guessing, but anyways. And the C negative runs right to the bottom of this first rectifier, where you have your line in right here, or the variable line in. The C negative comes out the bottom of that first diode and, goes in there. So it looks like it has one diode. I'm guessing it's anyhow. And that really messed me up with the camera stopping. Anyhow, the voltage one, it runs to the center of the diode pack. The amperage one runs, the amperage one runs to the center, and the voltage one, voltage runs to the center, amperage runs to the gauge, V runs to the center, A runs to the gauge, and C negative runs to the side of this pack of diodes. So we're tapped in the middle of the pack, and we're tapped at the end of one of the diodes. So interesting. So it should be some sort of rectifier. Anyhow, I don't see anything that's going to blow up as you plug it in. So let's see what kind of voltages this actually produces. There's no capacitors for cleaning up the signal, so there's probably going to be a lot of bleed through. There's no, I didn't see a transformer unless there's one built into that rheostat. Let's plug it in. It didn't do anything, so I guess that's a good thing. These I'm not too worried about touching because clearly they're not hooked up, but these 3 are hooked up. That's part of why I'm wearing gloves. Offer a little protection, but I didn't want to big, thick, heavy ones where I couldn't. Yeah, for some reason this thing keeps shutting off and it's annoying me. We're right back. Anyhow, back to where we were. Power on. Since it has that pack of diodes, it's probably running DC. So let's put it on DC. I'm going to go to 1000 volts just to make sure, and we can drop it from there. C seemed to be common, and V is coming from the center of that terminal. So what this is, we should get something like this: 103 volts, 110 volts. It's all the way up. We're getting 110 volts of DC, is what it says. I'm going to have to put a scope on this eventually. 0 volts all the way at the bottom. Somewhere in there. 25, yeah, so it's adjusting DC. So, which means I could have dropped this quite a bit further. Let's see what's doing on the AC side. Same terminal, same configuration. 251 volts of AC coming through this. Now it could be because it's just a bridge rectifier, there could be a lot of noise that my meter's picking up. I'm thinking it's probably noise. I've got to get a scope on this. Either way, it's still a lot of voltage. And it's adjusting it down just like it is the AC. But I'd almost be willing to bet that that's noise. Anywho, let's try the other pins. Same common. We're going to go to the A, the one that's running through the gauge. DC voltage is 120. It's above 20. Okay, the voltage is bouncing around on this one. All the way up, 30.9 volts. DC. See, we're getting on the AC side. 40 volts AC. Okay. Well, if that is a rectifier, it's not working. Yeah, just out of curiosity. Make sure we're all the way up there. Nothing between V and A. In AC, that is. Nothing between V and A DC. I didn't expect to. That's running through a diode. 1 volt negative. Not, nothing more than bleed over. So, what do you guys think? Comment if you want me to check anything else on it. I will. It clearly produces voltage. I mean, it's power coming in. It's clearly feeding voltage in and feeding voltage out. It looks like, unless my meter is just lying to me and reading a pulse, which I'm going to have to get a scope, and I'm buying one next week, a small scope, so you'll probably see some scope videos when I get that thing to play with. Just a little pocket scope. I go into it. Okay, this will be the last time because this thing is pissing me off. Maybe I should buy a camera. Anyhow, back to what I was saying. Let's unplug this before I shock myself. Although that would be amusing, wouldn't it? There's no capacitors in it. There's no transformer other than the old school rheostat that it's using, and I'm sure that has some sort of transforming property, but it looks like it's doing some sort of a crude voltage doubling if it's truly putting out AC. If it's putting out just really dirty DC, then they're using a transformer to drop the voltage, and what we're getting max out is about 100 volts. And they're just transforming it down. Either way, the rheostat, the gauge, the diodes, and a wire, if there's any part of this that you can think of that's going to be a cool project I can do, let me know. If there's any more tests you think I should run to make sure that we're getting a good idea of what this thing does, let me know. Because that is kind of confusing. That is definitely confusing output here. Let's see. Let's see if you guys can see that and get an idea of what that thing actually is. Probably not. Bring the camera closer. There we go. Alright, that's what that bad boy is. If anyone knows exactly what that is and what it's supposed to do besides just being a rheostat, which is pretty clear that's what it is, let me know. As always, like, subscribe, whatever you want to do. I know. It's always weird when you're having to hold the camera. So, that's my little $2 magic box. Like, subscribe, try to bring more videos. Yeah, the light in my garage is terrible. It's coming through the window and everything. But we're working on it. I'm sure you've seen the video of what I was starting with, and this is so much better. Yeah, it's still a mess, but at least I have walls now. All right. I'll see you guys later.